to talk with your neighbor, turn and talk with your neighbor. Let them know exactly what something new you learned in the video, or what's something in the video that surprised you. So right now, turn and talk with your neighbor, talk about that video.
Knock, knock.
New things you learned. What's some new things you learned after watching that video?
That there's, I guess, the data is inaccurate. That's one thing I didn't know before. I knew that there's a function problem with the vision.
Yeah.
But yeah, that is a big problem that the important to know.
Did you see the rate that it was declining by? It went down like really fast. What about you, Derek? What do you think?
Now it's going down a lot.
It's going down a lot quicker. Thank you, Derek. Okay, we're gonna do a. Thank you guys for turning and talking about the video. We're gonna do a quick whole class share out. Who would like to share something that they talked about during their turn and talk in the last 45 seconds? Jesse, go ahead. Can you be a little more specific about what about the fish?
There's an estimated 5 billion that was unknown example ocean, which is 50% more than the estimated population.
Yeah, there's 50% more fish than that was taken out of the ocean that we didn't know about. Yeah.
Peruse?
Anyone else have anything else to add to Jesse's comment about the video? Shay?
I guess that it being more than it was before, like more than it was thought to be, it becomes a bigger problem than it was in the past.
Yeah, being more than it was thought to be becomes a bigger problem. Yep, absolutely. Yep. We don't want this problem to escalate anymore. We don't want the amount of fish to run out in the ocean because it's a very valuable resource to us. Yeah, thanks for sharing that. All right, we're gonna move on. Today we're going to learn a little bit about carrying capacity and how changing the amount of resources available can affect the carrying capacity. Before we jump into the simulation, I just want you guys to take a look at some graphs of what carrying capacity looks like. Here's an example of a graph. This displays time, this displays the population. You notice over time, the population increases, but after a certain while, it starts to level off. And this is what we're gonna know as carrying capacity. For this graph, I want you guys to turn and talk with your neighbor right now. What is the carrying capacity of this graph? Turn and talk with your neighbor. What is the carrying capacity? All right, let's bring it back. Giselle, do you know the carrying capacity for this graph? Not sure? Shay, do you know the carrying capacity for this graph? 65. If I draw a line at where it started to level off, I'm going to read the population on the side, and that's going to be my actual carrying capacity. So it's around 65. So that's the carrying capacity for this graph. We're going to move on to the next one. What's the carrying capacity for this graph? Turn and talk with your neighbor. What is the carrying capacity for this graph? All right, let's bring it back. Mickey, what do you think the carrying capacity for this graph is?
90, like maybe 90.
95. So you think it's around here? Does that look about right? You think so? Okay. Anyone else have any other guess for what this carrying capacity is? Victoria, what do you think the carrying capacity is for this graph? You think 80? So you think it's around there? Okay. Yeah, so it's definitely around 80 because after you see that spike, it does go up to 100, but after it goes back down, right? And then it starts to
Level
level off. Yeah, good. Once it starts to level off, that's how you know that's where the carrying
out.
capacity.
Big word. Big word.
We're gonna jump into some quick guided notes. So right under your warm-up, you guys have 5 different steps for the tuna simulation. So right now, make sure you're following along for those 5 different steps right now. Let's make sure we have this page open. Marcus, make sure you got the page open. Alright. First thing you're gonna do is you're gonna open up the link on Google Classroom, and I see the front table all taking notes right now. Thank you, front table, for taking notes. I see Tomak taking notes, thank you. Second, you're gonna select skip tutorial. You're gonna get started straight into the simulation. And then finally, you're gonna see 3 different variables in the first stage. The first one you're gonna see is reproduction. The second one is migration. And then the third one is depth. So these are the 3 different variables that you're gonna be able to change within the simulation for the first stage. Thank you, Chung. Thank you, Catherine. I see them writing it all down. I see Jesse writing it down. Thank you. For the first one, we're gonna keep it. We're gonna keep it all. We're gonna keep the sliders in the middle. When you see a slider, it's gonna look like this. So for the first stage, all of the sliders are gonna stay right in the middle. Okay. And then finally, you're gonna press. Wesley, can you 45 your computer, please? Thank you. You're gonna press play, and then you're gonna wait for the graph to move. And then once the graph is fully done, you start charting it out. Okay? So I'm gonna go over an example of it right now. Wait, actually, we're gonna do a quick CFU. Victoria, where can I find the link to the simulation? Marcus, what are the 3 variables I can change? Reproduction. Yep. And number 3, where on the slider do I put for the 3 variables? Where on the slider do I put it?
In the middle.
Marcus?
In the middle.
In the middle? Yep. Got it.
What's the last one? Number 5.
What do you mean number 5?
Alright, thank you. Thank you, sir.
I'm gonna show exactly what you're gonna be doing. So on our our computer should still be at 45, so don't have your computers open quite yet. Come on. Done. So on Google Classroom, we have a tuna simulation. You're gonna click that simulation. You're gonna click Start. You click Skip Tutorial. You click Start First Scenario, and then you're gonna have your first stage open. The first thing you're gonna do is you're gonna make sure all of the sliders are on the middle. You're gonna click play on the bottom right here, and that's how you're gonna get the graph. On your second page, you guys have a graph for the first stage. Click play when the sliders are on the middle and start beginning on those graphs. So right now, take the next couple minutes, make sure you have the tuna simulation open and start on the graph right now. I see Francisco getting started on the first stage. Thank you, Francisco. I see Chong getting started on the first stage. Thank you, Chong. Make sure you're doing the graph as soon as you have it. Make sure you're writing it down too. You're getting it open right now. I see Giselle getting the simulation open. Thank you, Giselle.
It's Gazelle. It's called Gazelle. It's a little gazelle. It's a baby gazelle.
They're all down in the middle, so click play.
How's your day, Miss Ball?
I see Shay has the simulation open. He's doing the first graph. Thank you, Shay. What do you notice after 5 years? What's happening to the population? It stays stable. So what do you think? What's the reason for it staying stable like that?
They have enough resources for it.
They have enough resources for it? Why wouldn't it be increasing?
Because then they're like dying at the same rate.
They're dying and
Reproducing
at the same rate?
Yeah.
Thank you.
Wish I could.
Thank you, Catherine, for getting started on the simulation quietly.
I would, but I'm not.
Someone? Simulation?
I can do this.
You're using Donnie's?
Yeah.
You guys can all share? Okay.
Can't see it.
Yeah, so put it like where Tamak is so that you guys can all work on the simulation together. And you guys should have the second page open. Donnie, do you have the handout?
Yeah, just check.
Okay. Make sure we're on the second page right now, so we're good to go. Tamak, what's the second page? Second page. There you go. It's on Google Classroom, so if you go on Google Classroom, that's where you'll find the solution. Thank you, Victoria. Thank you, Jessica, for starting on the first stage quietly. So, not to just skip the tutorial, you need the tutorial. Skip. Then you start it. And then you're going to do the first graph. So just click play, and then you're going to graph that out on your first stage. There you go. I see Talia starting on her simulation. Thank you, Talia, for starting on
And
the
then
first
after,
simulation.
when we do that, we got it back.
Catherine, what do you think is happening? Why is the graph staying? What's happening during that graph?
Like it's increasing like the population, but then it stables itself because like there's enough plants for the tunas, but like it's not really increasing or anything.
You said there's enough plants for the tuna, but it's not really increasing or
Yeah.
decreasing. Why wouldn't it be increasing any more than that?
Because the amount of tuna ate it, so that it can't like increase.
So there's not enough resources for the other tuna to grow more? That's what you're trying to say?
Yeah,
Okay.
just like enough.
Okay. Thanks, Catherine.
Hello.
Thank you, Alex. Thank you, Francisco, for working on the graph. Alright, y'all, we're gonna work. I see some of you guys still finishing up the first graph, which is awesome to see. But right now we're gonna work on the second graph. Some of you guys already got started on it, but the thing about the second graph is that I want you guys to predict what will happen to the population over time. Given that it's okay, you have two graphs.
I need help.
So right below, come on. Right below that first graph where you already right below the first graph where you already plotted all the points, that second graph, I want you to not start the simulation quite yet. I want you to just predict what is gonna happen if you have these two sliders like this. You see that the food is at abundant, whereas the predators are at none. So how do you think that graph will look? So for the bottom graph, predict how you think it will look. So let's start on that right now. Thank you, Francisco, for starting on the second graph. Thank you, Marcus, for starting on the second graph. Let's make sure we're all doing a prediction for that second graph. Second graph right now.
I need help.
So given that there's a lot of food and that there's little to no predators, what do you think the graph is going to look like over time? given that there's a lot of food and little predators. Yeah, just draw. What do you think it's gonna look like? Like that? Make sure to also include the label so that it's good to go.
Population. I'm lost.
Oh, populations right here, years are right here. And the labels are the exact same as this graph up here. I see Catherine, I see Mickey finishing up that second graph. Make sure you finish up that prediction right now. So you predict it's gonna look like that. Alright, I'll take about 20 more seconds to finish up that prediction for your second graph. 20 more seconds to finish up your prediction.
See that, you said.
Thank you, Jesse, for working on this graph. Jesse, you got a question? You're already on the third stage. So for the third stage, you're just gonna put it where you want it. So you're just controlling the variables for fishing, and you're just gonna put it where you want it. You graph it on the next page. Yeah. Good question. Thank you, Francisco, for finishing up the graph. All right. Right now, you're gonna run the simulation for the second graph. Make sure that you put food at abundant and you put predators at none. Make sure food is at abundant and predators at none. And start your simulation for the second graph. And you're gonna put the graph underneath the actual graph. So that's where you're gonna put this graph. Is you're gonna put it underneath the actual graph. Okay. So do that for the next 2 minutes. Make sure you finish up that graph. Note that disease occurs halfway through. So if you see a dip in that population, it's because there's a disease that occurred. Okay? So let's get started on that next graph. Thank you, Jessica. Thank you, Victoria, for getting started on the second graph. Is that the first one? Oh, okay. So you're just grabbing them now. Okay. Do you know why the population stays at the top like that? Little deaths and a lot of reproduction. Yep. Thank you, Mickey, for finishing up the graphs. Let's make sure we're all finishing up the graphs. How are you guys' graphs looking? Which stage are you guys on? The first one? Okay, move on to the second one. Because you guys are already done with the first one.
Tuna simulation.
So right beneath, or next is stage 1, it says stage 2. Yeah, right there. There you go.
Right there.
And then where are you supposed to put the sliders? You remember? So if you look on your paper, where does it say you're supposed to put food and predators?
On the graph. Like.
Oh, for the sliders. So where's food at?
Oh.
Yeah, so you gotta change it. There you go. Yep. And then once you do that, just graph it and then write down the graph on your paper. Wait, Donnie, come on, did you get that?
Yeah.
So make sure you guys are writing. Donnie, come on. Make sure you're getting Donnie.
Donovan.
Yeah.
Make sure you're getting that graph down, okay?
Okay.
Thank you. This is for another class. Oh. Yeah. So did you get the actual graph for the second one? For stage 2? Yes. Yep, exactly that one. So just make sure to graph that. Oh, Derek, you got a question?
Put the graph on this.
The actual graph. That's the prediction one. That's the prediction one. And then the next one on the next page, that's the actual graph. But it's okay. Did you put the actual one right here?
Yeah.
It's okay. It's fine. You were just supposed to do the prediction first and then the actual, but it's no biggie. Just focus on the next stage. Okay.
Okay.